So this is a very classic higher level question because there's something unfamiliar about it. Sine of pi of cos x. You've not seen much of that before. But you mustn't let that put you off. You're going to see a lot of unfamiliar things in higher level questions, but they're all absolutely on the syllabus. So this one is a very straightforward question in one way. Find the coordinates of the stationary points. Obviously, that just means dy by dx equals naught, so we're going to differentiate this. This is not actually a very difficult thing to differentiate. It's just a chain rule. Differentiate the inside function, put a big multiply sign, and then say to yourself, what happens when I differentiate sine of something? Well, you get cos of something. And that's the end of the calculus part of this question. We now switch into a different mode. I've got to solve this trig equation. So in trig equations now, we have two things being multiplied together that are equal to 0. So either one of them is 0 or the other one is. So start with the easy one. Maybe this left-hand one is equal to 0. Let's write it down. Treat it as a separate question. So when I realize that this minus pi is just a constant, you mustn't let the pi distract you when you differentiate it, or in here, this just means sine x equals 0, and without a calculator, you should be able to picture the sine curve going up and down, naught and pi, easy. So the next thing is maybe the other bit is 0. Less obvious what to do here. This is reading cos of something is equal to 0. So let's just inverse cos. Let's just say, well, what angles make cos equal to 0? Can you picture the cos curve? When is it equal to 0? Well, it's either equal to 0 at 90 or 270. So therefore, this cos of pi cos x must equal 90 or 270, except we're dealing in radians. So pi cos x equals pi by 2 or 3 pi by 2. I'm already saying to myself, I'm going to treat these as two separate questions. Let's divide everything by pi, and we've got two separate questions. Let's deal with this one first. Cos x equals a half. You should be able to do that. We get the triangle as a 1 and a 2 in it, and you should know that that is going to be 60 degrees. Cos of 60 is a half. And you then think to yourself, right, it's 60, or the second solution for cos is 360 minus the first, so 60 or 300. But the question said 0 to pi, so I'm just going to get 60, again, written in radians. And I, as a discipline, always write the second solution down and then just immediately cross it out. Saying to the examiner, but a lot saying to myself, I have thought about the second solution and not just been happy with one solution. Whenever you cross out a second solution, you should think to yourself, can I replace it? This is only the first and second solution. There's an infinite number of solutions. We can get all the other solutions by adding 2 pi or subtracting 2 pi. Clearly, adding 2 pi is just going to make it bigger. Subtracting 2 pi makes it negative pi by 3. And that's not in the domain either. It said 0 to pi. Fine. So I've really thought about that. Okay, that's done. Let's go back to this one. We had pi cos x equals 3 pi by 2. We divided by pi. But cos x can't reach as high as 1.5. Cos x only goes up to 1 and down to -1. So I can cross that out. Hold it, though. I've crossed a solution out. Can I replace it? Well, here's my two solutions to this trig equation. Let's subtract 2 pi from this one. And I get cos x equals -1/2. Now, you should not be thinking, oh, I can cross that out because -1/2 is not in the domain. No, we haven't got to an x value yet. I've got to do an inverse cos of -1/2. Now, the way you handle negatives is you compare them to positives on the diagram. So I've drawn -1/2 and +1/2 on the cos curve. And I know that cos of 60 is a half. And from this diagram, I can see what angle will give me -1/2 by symmetry. that one's 60. This distance here is 30. Well, that one must be 30. So 120 is, cos of 120 is minus a half. There's another one over here, but that's gone beyond 180. So there we go. I've got 120 degrees, which I'm going to write in radians. And there's the answer to the question. Pi by 3, 2 pi by 3, plus the 0 and 2 pi. Let's just confirm that on the calculator. So if this was a calculator question saying find the stationary points, just type it in, draw it. There's a minimum here and a maximum there, minimum here, maximum there, 4 of them, exactly where we said they were. That's it.